Good evening, everyone. My name is Benjamin. You can call me Sir Ben. I'll be taking you on chemistry this evening, and this channel is Exam Help and Care Academy. So, on this channel, we look at past questions and topics on chemistry, physics, and mathematics. So, today we'll be taking the subject chemistry and we'll be looking at Graham's law of diffusion of what? Gases. Definitely the topic is under gas laws. There are some gas laws you should know about, which you did in your SS1. We have the likes of Boyle's law, we have Charles' law, we have general gas law. That's a combination of both Boyle's law and gas laws. Then aside the general gas law, we now have Graham's law of diffusion of gases, and we also have Gay-Lussac's law. So all these are part of the gas laws. Okay, so we'll be looking at Graham's law this evening. So the first thing we'll be looking at is the Graham's law. Now, the Graham's law, how is it stated? Graham's law states that at a constant temperature, pressure, at a constant temperature and pressure, at a constant temperature and pressure, include, I have to add that there, at a constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its what? Density. The rate of what? The rate of diffusion of a gas is inversely proportional to the square root of its density. So now, what does this mean mathematically? When you state that Graham's law of diffusion states that at a constant temperature and pressure. Now, at a constant temperature and pressure, the rate of a gas is inversely proportional. This is the sign of proportionality. So, rate is inversely. Inversely means 1 over a certain number or 1 over a certain constant or identity, whatever it should be. So now, when I say R is inversely proportional to density, the square root of its density. So the square root of its density. So R is equals to K over D. So where K, whenever you're solving anything involving proportionality, that's the proportional questions in both maths or maybe anywhere, you involve the K. The K shows you the link up between both variations. The topic is variation in mathematics, so it shows you the link up between both variations of two entities. So now it will show us that of rate and the diffusion of the gases. So now where K is a constant. Now comparing the rate of diffusion of two gases, now you might be given two gases. One will be known and one will be unknown. So we'll be solving some questions this evening. So now comparing the rate of diffusion of two gases, we said that the rate R1 all over R2, the first rate of the gas over R2, is equal to all in square root the density of the second gas all over the density of the first gas. So that is comparing the rate of diffusion of two gases. So R1 all over R2 is equal to all in square root D2 over D1. Now, I do tell students most times, whenever, because most of the things in physics, chemistry, and mathematics has to do with formulas. So for you not to forget this formula, whenever you're writing R1 over R2, just note that the other one in the right hand side by the square root is going to be this way, as if you're taking an X this way, so you don't forget. So the D are both, we have both D and D at the numerator and the denominator, so the D up should be D2 and not D1. So D2 here, D1 here against R1. Alright, now we move further to say that since the density of a gas D, the density, D stands for the density, is proportional to its relative molecular mass. Remember, you have relative molecular mass in chemistry, showing you the relative atomic mass of that gas. all right, or maybe that element, not just gas, because we have 3 states or 4 states of matter, especially in chemistry and physics. We have the solid, liquid, and gaseous world state in physics. We move further to plasma state. All right, this relation can also be written as R1 over R2 is equal to all in square root M2 over M1. So don't forget again, M2, R2, R1, M1. So it says that rate is the rate, the rate is the rate of time. Rate is the what? Rate itself is inversely proportional to time. Sorry, this has to be corrected. Rate is the reciprocal of time. So I'm going to clean this here. Rate is the reciprocal. You can't say rate is the rate of time. No, that's a grammatical error. So we say rate is the reciprocal. Is the reciprocal of time. So now, what is reciprocal? Reciprocal is 1 all over a certain item or 1 over a certain number. So R is equals to 1 over what? T. So now, what about if you say R1? Because you always have one rate and the first rate and the second rate. So when I say R1 itself is equals to 1 over T1, then R2 is equals to what? Equals to 1 over T2. And remember, the formula states that R1, okay, let's start from the beginning. R1 over R2 is equal to all in square root M2 all over M1. Good. So I have R1 all over R2 is equals to M2 all over M1. Likewise, you still have R1 over R2 is equals to the diffusion of the two gases. That is, it is still equal to all in square root, sorry, D2 all over D1. So you can say R1 over R2 now is equal to, now we said that rate is the reciprocal of time. So if R1 over R2 is equals to this molecular mass M2 over M1 and D2 over D1, then definitely it's going to still be for the time. So we'll now have T2 all over what? T1. It's going to complement. Let me prove this for you somewhere here. Because mathematically you have to prove this, that this is correct. That's this. It's saying that R1 over R2 is equals to T2 over T1. Let's prove if it is correct. Now, this is what you do. Your R1 is 1 over T1. 1 over T1 is equal to, sorry, R1 is 1 over T1. R2 is divided, or let's write it the very way you understand this thing now. R1 over R2. Your R1 is 1 over T1 all over 1 over T2. So taking that, this, we say 1 over T1 divided by 1 over what? T2. Now, this is 1 over T1. Remember division of fractions. In division of fractions, we have changed this division sign to multiplication sign. Then T2 goes up and your 1 comes down. So it becomes T2 over T1. I think you can see this now. So that's why we have R1 over R2 is equals to T2 over T1. So definitely I can also now put my formula this way. Can I say T2 all over T1, that's this R1 over R2, which is equals to M2 over M1, is still equal to all in square root D2 over D1, or T2 over T1 is still equal to all in square root M2 over what? M1. So this is just the difference in this and the first one. The first one will always be R1, R2, then this way, or R1 over R2 is equals to D2 over all in square root D2 over D1. So we now have some formulas here. So what I'm going to do now is I'm going to write down a question. So when I write down this question, then we'll now solve the question using any of these formulas. Yeah. So just hold on so that I will write the question. I'm going to pause the video, then write down the question, then we'll continue. Alright, I'm through with the question now. So the question before us says 80 centimeter cube of chlorine gas. 80 centimeter cube of chlorine gas. Let me be sure that that's what I copied. So it's an 80 centimeter cube of chlorine gas. Okay, yes, correct. Diffuses through a porous pot in 60 seconds. Why it takes 90 seconds. 80 centimeter cube of chlorine gas diffuses through a porous pot in 60 seconds. Okay. Why it takes 90 seconds for the same volume, volume of an unknown gas to diffuse through the same pot. Now it said calculate the relative molecular mass of the unknown gas. Now you were given the relative atomic mass of chlorine, which is the chlorine gas, which is 35.5. So that's the relative atomic mass or the relative molecular mass of what? Of chlorine. So we are going to solve this question now. So to solve this, we are going to apply the formula for the given question, which is the topic which we are looking at, which is Graham's law of what? Diffusion. Graham's law of diffusion of what? Gases, which is our topic on this chemistry. Talking about Graham's law of diffusion of what? Gases. Yeah, Graham's law of diffusion of gases. So let's write this down before we solve, which is very important. Now, solution. First of all, you have to bring out the parameters. And I've always told students there are 3 tricks which are used in solving any external questions. One is that you should be able to read the word question. If you can be able to read the question, then you should now be able to identify the problem. That's know the topic, where it is being gotten from that subject. Is it maths, physics, or chemistry? What particular topic is this? So if you be able to read the question, understand the question, which is not that number 2 law, then you should be able to solve the question. That's the number 3. So first of all, you should be able to read the question. Second, you should be able to identify the problem. So if you can read the question, identify the problem of the question, then you will now be able to solve the question. So now we'll bring out the parameters out. Now 80 centimeter cube of chlorine gas. So they gave off 80 centimeter cube of chlorine gas. As science students, the chemical symbol for chlorine is Cl. Yes, but since it's diatomic, I'm going to put Cl2. So take note, chlorine is diatomic. So the chlorine gas, so 80 centimeter of chlorine gas diffuses through a porous pores in 60 seconds. As the time rate is 60 seconds. Now, why it takes 90 seconds? So 90 seconds for the same volume of an unknown gas. So unknown gas, don't know this gas, unknown gas. So now this unknown gas, the unknown gas, let's call it maybe P gas. Is that understood? So unknown gas, P gas itself, the unknown gas, P gas itself, the time rate is 90 seconds. Do you get that now? So 90 seconds. So now that's the time rate for the unknown gas. Now the time rate for the unknown gas is 90 seconds. He said again that 90 seconds for the same volume of an unknown gas to diffuse through the same port. Now he said calculate the relative molecular mass of the unknown gas. Now the relative molecular mass of the known gas, that's M, relative molecular mass of chlorine is 35.5. We'll now multiply it times 2. Why? Because it is what? It is a diatomic element, chlorine. 35.5 times 2. And I think if you do 35.5 times 2, it should be giving you 70 point something there. Let's confirm. 35.5 35.5 times 2. Okay, that should be giving us around, it's even above that, but 35.5 times 2. 2 times 5, 10, put down 0, carry 1. 2 times 5 is what? 10. Then plus that one, 11. And 2 times 3, 6, plus this one, 7. That's 71.0. So we have 71.0. Okay, so we keep that. Now we're going to wipe this off. Don't forget that this is now our relative molecular mass for chlorine. Okay, remember the question says calculate the relative molecular mass for the unknown gas. So the relative molecular mass of Y, okay, not Y, sorry, P gas, of P gas, which is not given, which is the we don't know it, unknown. So using the formula, what were we given? We are given the volume, we are given time, we are given we're not given the volume of this, but it says, look at this again, it said why it takes 90 seconds for the same volume of an unknown gas. Okay, sorry, we're given the same volume, so the same volume, unknown gas, P gas, time rate is 90 seconds, but the same volume. So 80 centimeter cube of chlorine gas diffuses through a porous port in 60 seconds. Why it takes 90 seconds for the same volume of an unknown gas? So I'm supposed to still write 80 centimeter cube here. So take note, 80 centimeter cube of unknown gas. So what we are just looking for is the time rate. So 80 centimeter cube of what? Of the same P gas, which is the unknown. Unknown gas. So now solving this now, what and what was given. Remember your formula, R1 over R2 is equals to what? Is equals to all in square root. First of all, diffusion D2 over what? Over D1. Then the same formula is still equal to all in square root M2 all over what? M1. And the same formula again is still equal to what? T2 over T1. T2 over what? T1. So now we are given rates. We're given molecular mass, yeah, and time. So we use T2, let's say T2 over T1 is equal to all in square root M2 over what? M1. So that's what we were given. We're given time rate of the time T2, T1, M2, M1. So if we say T2, T1, so what is T2? Now, let's say that arrow 1, we change it to the rate of the first gas, which is rate of chlorine. So arrow 1 will now be RCl. So R2 will now be rate of P gas, the unknown. So if this one was R1, this, so diffusion of chlorine, Cl, D2, this. So what here will now be is diffusion of what? Of P gas. Are you getting that now? Good. So my M2, definitely say R1, R2, M2. So M2 is still going to be what? It's going to be, let's say, RCl over RP gas. As R1, R2 goes to all in square root M2. The M2 itself is P gas, so M molecular mass of P gas over molecular mass of what? Chlorine. Moving this way, moving this way. So now the rate was not given. What was given was the time. It was the time that was given. So what are we looking for? Remember, time for T2. Remember, this is R1, R2. So T2 definitely is time rate for P gas. Tp over T1 chlorine all over all in square root M2 is the MP gas all over mass of chlorine. Yeah, so you just have to memorize this. So just take a look at it very well. Don't worry, it might look complicated, but please, it's not that complicated. Remember, before, what was written here was R1 over R2 is equal to D2 over D1. So now my R1, I changed it to what? Rate of chlorine, then rate of the unknown gas. So if here was 2, here was 2, so rate of P gas, diffusion of the what? Of P gas. The rate of chlorine, diffusion of what? Chlorine. Mass, now M2. So I think definitely if you're saying M2 now, your M2 should be mass of P gas. That's the molecular mass of the unknown gas. The M1 should be the mass of what? Chlorine. Chlorine. Very good. So we'll wipe here off, then we'll start solving immediately. So now, wiping this off. I'm taking my time because this is chemistry. I want you to understand the calculation very well. Oh, I've cleaned the question, but don't worry, I'll read it out in case it requires. Now, what's the time rate for P gas? P, which is unknown. It said 80 centimeter cube of chlorine gas diffuses through a porous spot in 60 seconds, while it takes 90 seconds for the same volume of the unknown gas. So P gas, which is the unknown gas, the time rate is what? Is 90. So I can say Tp 90 seconds, then time rate of chlorine, if I'm correct, should be 60 seconds. Mass, molecular mass of unknown gas is what we are looking for. P gas, the mass of chlorine gas. It is what? 7.10. 71.0, sorry, not 71.0, just approximately 71 to the closest whole number. So now, solving this now with this formula, we are looking for MP itself, mass of the unknown gas. So we now say, we're going to say TP all over chlorine equals to all in square root MP all over mass of chlorine diatomic. Now, to make MP subject of the formula, we are going to take the square of both sides. So taking the square of both sides, take the square of both sides to make a mass of P gas the subject of the formula. So to do this, what I will now do, I will now be all in square root Cp over TCl2 squared is equal to MP over MCl2. So definitely this is off. The square root of this is off. Then what you now do, you now cross multiply. Cross multiply. Cross multiply. You times this, leave this one, making MP the subject of the formula. So MP Cp over T2 squared times MP. Molecular mass. Is it MP? No, sorry. Mass of chlorine. Mass of chlorine. So MP gas what's the time rate of P? Time rate of P is 90 all over time rate of chlorine 60. Don't forget, put it in brackets, squared, times, then the mass rate of the chlorine gas is 71. So MP gas, 0 cancels 0. So if you do 9 divided by 6, that is 9 divided by 6, correct? Or you say 6 divided 9. That should be, if 9 divides 6, 6 here 1, 6 in this will be 1 remainder. I think 6 plus 3 should give us 9. Yeah, so it should be 3. Add 0. This should be point. 6 divided 30, that's 5. So that should be 1.5. If I'm correct, yes, 1.5. So definitely we'll now say 1.5 all squared times 71. So wipe this off now. So wiping this off to continue my calculation. I know some of you will be like, all these things are so bulky. Well, it's bulky because you are just learning it at the first time. But by the time you become an expert, you don't need all this long explanation, because what I'm just doing is I'm teaching you. Okay, so the MP gas, as the mass of the unknown gas, is equal to 1.5 squared, right? Okay, 1.5 squared, if you do that with a calculator, 1.5 squared then times 71, it will definitely give you 1.5. If I use this 1.5 squared, it's giving me 2.25. Then times 71, it will give me 159 point approximately 8, 1.598. So this is 2.25 times 71, which is equals to 159 point approximately 8. I approximated it to be 8. 2.25. .5 squared. Sorry, my answer failed. 2.25. Alright. So we have gotten the MP gas as the molecular mass of the unknown gas. So it is 159.8. So if you approximate this to the nearest whole number, this should be approximately 160. As this changes to 10, put the 1 here, becomes 160 approximately. Alright, there's still a second method. There's a second method, right? What is the second method like? What's the second method like? I think I'm going to pause this video and do the second method. Alright,